Today we're going to be looking at how to find mean absolute deviation. This is actually information from the 6th grade book that they assume that you have had already. But of course you may or may not have done it in 6th grade and you may or may not remember it. So we're going to review it here today. Our I can statements for today are I can find mean absolute deviation and I can use measures of center and variation to compare populations. So here are the steps for finding the mean absolute deviation. The first thing we need to do is to find the mean of the data. That's when we add the numbers together and divide by the number of numbers. The second step is to find the distance between each data value and the mean. That means we're going to be subtracting. Step 3 is to find the sum of those distances in step 2 and then divide the sum. So basically you're finding the mean, you're subtracting your numbers with the mean, and then you're finding the mean of your new numbers. Mean absolute deviation tells us about how far apart the numbers are spread. Okay, so let's take a look at this one. You record the numbers of raisins in 8 scoops of cereal. Find and interpret, so that means we're going to have to explain something, the mean absolute deviation of the data. Okay, so our first thing that we're going to do is we're going to find the mean. So I need to add all my numbers together. 1 plus 2 plus 2 plus 2 plus 4 plus 4 plus 4 plus 5. So I'm going to go ahead and add that. So when I add those numbers all together, I get 24. They told me it was 8 scoops of cereal. That's why I have 8 numbers here. I'm going to divide by 8, and I'm going to get 3 as my mean. Now, if for some reason you get a number that's really long with a decimal, you can round to the nearest tenth. Okay, so now I'm going to subtract each number with 3. Now, depending on whether or not the number is bigger or smaller than 3, I'm always going to subtract in a way that gives me positive answers. So, for example, my first number 1, 3 is bigger. So I'm going to do, whoops, that's my eraser. I'm going to do 3 minus 1. And I'm making a new list of numbers. So that's going to be 2. All right, now I'm going to do 3 minus 2. Okay, that's 1. 3 minus 2 again, still 1. 3 minus 2, again, still 1. And now I have numbers that are bigger than 3, so I'm going to subtract them from 3. So 4 minus 3. When I do 4 minus 3, I get 1. 4 minus 3, I get 1. 4 minus 3, I get 1, and then 5 minus 3. So I've taken each number, and then I've subtracted it with the mean in a way that's going to give me a positive answer. So now I'm going to find my mean of my new numbers. So I'm going to add them together. 2 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 2. Okay, so that gives me an answer of 10. I still have 8 numbers, so I'm still dividing by 10. I'm sorry, still dividing by 8. So I'm going to go ahead and do 10 divided by 8, and I get 1 and 25 hundredths. Unless they tell me to round my MAD, I'm not going to. I'm just going to write the exact answer. Okay, so 1 and 25 hundredths, that's my mean absolute deviation. Okay, so interpret, this is about numbers of raisins in 8 scoops of cereal. The MAD tells us the distance from the mean. So I'm going to write on average, the number of raisins is about 1.25 away from the mean of 3. So most of our raisins were really close. Maybe one above, maybe one below, occasionally more than that. But on average, they're about 1 and 25 hundredths away from the mean. That's what the MAD tells us. Okay, so let's take a look at this next one. Find and interpret the mean absolute deviation of the data. We're going to do the same exact steps. Go ahead and pause for a minute and try this one on your own. So first step here, we need to find the mean. We're going to add all of the numbers in my list together. And we're getting 96 for our total. We need to divide by the number of numbers. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. I have 8 numbers. So when I divide there, 96 divided by 12, I'm sorry, divided by 8, I get 12. That's my mean. So now my next step is to take each number and subtract it with 12 to figure out how far away from 12 it is. And you always subtract in a way that's going to give you a positive answer. So I'm going to do 12 minus 5, that's 7. 12 minus 8, that's 4. And 4 again, because I have another 12 minus 8. Okay, and then, let's see, there's my 12 minus 8. I have 12 minus 10. It's going to be 2. Now my numbers are bigger than 12, so I'm going to start with the number given to me first and then subtract 12 from that. So 13 minus 12 is 1. 14 minus 12 is 2. 16, whoops, I don't want to write divided by. I want to write minus. So 16 minus 12 is going to be 4. And then 22 minus 12 is going to give me 10. So that's my new list of numbers. To find the mean absolute deviation, I need to find the mean of those numbers. So my next step is to add them together. 7 plus 4 plus 4 plus 2 plus 1 plus 2 plus 4 plus 10. I need to add all of those values together. All right, and then when I do that, I get a total of 34. I'm going to divide by 8, just like I did in my last one. I still have 8 numbers, or just different numbers this time. I get 4 and 25 hundredths as my MAD. Now compared to my last one, that means my numbers are much more spread apart. The last one, they were all very close to each other and close to the mean, but here I have a lot more spread, a lot more distance to my numbers. I don't really know what this situation is about. It's just a list of data. So I'm going to just write the data is about 4.25 away from the mean of 12. All right, let's take a look at a story problem situation. So for this one, smartphones show the number of runs allowed by 2 pitchers in their last 10 starts. So for A, we need to find the mean, median, and mean absolute deviation of the numbers allowed for the runs for each pitcher. Okay, so I need to calculate all of these different things. So mean, we're going to add them all together. We're going to divide by the number of numbers. I'm going to move this up a little bit so I can see the bottom numbers. Okay, so I'm going to start with Mendoza. Okay, so I'm going to start by adding together all of his numbers. Okay, so when I added all of those together, I got a total of 35. So for over here, I'm going to rewrite that number so you can see it a little bit better. So our mean, we got a total of 35. They told us there were 10 numbers there. So that means my mean is going to be the 3.5. That on average, the average amount of pitches he had, or sorry, runs, was about 3.5 per game. So next, I'm going to find the, I'm going to go ahead and do mean absolute deviation while we're doing mean, and then I'll do median last. So in order to do my mean absolute deviation, I have to take each number and I need to subtract with 3.5. Now I'm going to write my 3.5 first for all of these, but just know that if my number is less than, or my number is greater than 3.5, I'm going to do it, subtract it so that I get a positive number. It's just I don't have a lot of space here for that. So 3.5 minus 4, really 4 minus 3.5, that's going to give me a value of 1/2, 5/10. Now, if I do 3.5 minus 6, or really 6 minus 3.5, that's going to give me 2.5. This one will also be 2.5. 0, 3.5 minus 0 is going to give me 3.5. And let's see, 8 minus 3.5. 8 minus 3, let's think, is 5, so that's going to be 4.5. So 4 we already did above, that was 1/2. 3.5 minus 5, really 5 minus 3.5, that's going to give me 1.5. 0 is going to be 3.5. 3.5 minus 2 is going to give me 1.5. And 0 again is going to give me 3.5. So now that I have my new list of numbers, I'm going to find the mean for that list of numbers. I need to add them up, and then I'm going to divide by 10. Okay, so when I added my numbers all together, okay, I got 21 and a half. I still have 10 numbers, so I'm going to divide. Okay, that's going to be, whoops, helps if I divide correctly. That's going to be 2 and 15/100ths for the MAD. The last thing I need to do is to find the median for these numbers. So I'm going to go ahead and do that. I'm going to erase all these extra numbers so I can see my original numbers a little bit better. I need to order them least to greatest for the median. So I'm going to go ahead and do that. I want to make sure at the end I count to have 10 numbers. So I have 0, 0, 0. Looks like I have 3 of those. I have 2. I have 2 4s, 4, 4. I have a 5. I have a 6 and another 6 and an 8. Let's see if I got them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Great. So I have all 10 numbers. So median, I can cross them out or check them off side to side. When I do that, I end up getting the numbers in between the 4 and the 4, and that's going to be a median of 4 for Mendoza. Go ahead and pause the video and try the same thing for Rodriguez. Find the mean, find the MAD, and find the median. Okay, so I'm going to go ahead and just skip forward and show you my answers so you can compare them to yours. So I used the same steps that we did before here. So looking at Rodriguez and those numbers, it looks like I have the median, the mean was 3.5. Our median was 4, and our MAD was 1 and 4/10. So our mean and median were actually the same as the other one, but our mean MAD is slightly closer together. Okay, so let's take a look at this next one. It says the smartphones show the number of runs allowed by the 2 pitchers. That's the last problem that we just did. So which measure can you use to distinguish the data, and what can you conclude about the pitchers from this mean? So the one that's different is the MAD. The other ones are the same. So to distinguish them, we have to use the MAD. So the MAD is different. Rodriguez has a smaller MAD. So he is more consistent. Okay, and then our last one that we're going to look at here, it says Mendoza allows 4 runs in the next game. How would you expect the mean absolute deviation to change? And then explain. So if we go back to his numbers here, his mean the mean is 3.5. 4 is very close to that, so we would expect the MAD to be smaller. So 4 is very close. It's only half off. to mean, and that mean was 3.5. So he is more. Um, so his, actually, I'm going to erase this here. His MAD would be smaller.